Greetings, we are from Group 21 and we will be presenting about evolutionary neural networks for weather prediction.
This is our group member. First member is SITI Naqiyah binti Mahzan as 65699. The second member is NOOR SALIHA binti HAKIMI with metric number as 66614. And the third member is THULASICHELVI GOPINATHAN with metric number as 66516.
So I will begin with the introduction of our topic. Weather forecast has been around for a millennia, but formally processed since 19th century. For sectors as agriculture, for instance, it highly relies on weather prediction forecasts. Thus, they had ways to forecast weathers by developing wind force scale. From there, the evolution began. On 26th of October of 1859, the Royal Charter, which is a steamship, it sank in a storm, thus contributing to the establishment of modern weather forecasting. This report attempts to study whether the help of an intelligent system is able to aid delivering accurate weather forecasts. Intelligent systems have many approaches such as the expert system, fuzzy system, neural networks, and not to forget hybrid system. Hybrid system is actually a very interesting approach because it identifies the problem, considers the criteria that is needed to solve the problem, thus bringing together two or more approaches that best delivers a solution. There are many approaches in hybrid system. For instance, neural network, expert, neural fuzzy system, evolutionary neural networks, also fuzzy evolutionary system. Thus, in this report, we will take a deep look into the evolutionary neural network is able to aid in bringing accurate weather forecast.
So, the next part is methodology of the application. The first step is define parameter. In this step, we choose the size of chromosome population, either crossover, mutation, and training the epochs. For our topic, the parameter include the sensor input and geolocation. Then for the second step is define fitness function. In this step, the fitness function is defined based on many aspects, such as learning speed and network complexity. The sum of squared errors is used in this step, and in our case, temperature range and rainfall rate is used. For the next step is generate initial population. In this step is to represent the potential network architecture. We create an initial population of chromosome. So for the next step, which is the fourth, decode the chromosome. In this step, we translate each chromosome into neural network structure, feed-forward architecture, and prioritize ignoring any feedback connection. Then for the fifth step is evaluate fitness. In this step, the network is trained based on the real-time weather data. The fitness score is also calculated in this step for each network based on prediction accuracy. If yes, the step will proceed to selecting the parent. If no, it will return back to the decoded chromosome at the step 4. Next is select parent. After we decode the chromosome, we select the parents if pass the fitness evaluation. So in this step, we choose the fittest networks for reproducing using probabilistic method to best deliver the best quality of parents. For the seventh step, the crossover and mutation. This is the parameter that we choose from the step 1. In this crossover and mutation, the parent chromosome are combined and perform minor mutation to create diverse offspring. Next, for the 8th step, generate the offspring from the selected parent, where we form new generation of neural network from evolving chromosome. The next step is replace population. In this step, the parent population is replaced by the offspring that been generated from the 8th step, iterating to refine the network performance. Then lastly, for this algorithm, repeat the process. This is a decision one where if we want the cycle to be continued, then it will look back at the decode chromosome. If no, then it's gonna be the process will be end. So next for the result, evolutionary neural network is relevant to weather forecasting because this evolutionary neural network or ENN has a good adaptability and learning ability, make it highly effective for weather prediction where the conditions are constantly changing. The combination of uncertainty tolerance and knowledge discovered ensure that ENN can handle both unpredictable conditions and extract valuable insight from large dataset. From this table at the side, the uncertainty tolerance rate is good since AN is capable of handling uncertain or variable data, which is essential for weather forecasting. For the learning ability, ANN excels in learning from historical weather data, where they will improve the prediction over time. Next, for the knowledge discovery and data mining, NN is have a strong performance in this area, which allows it to identify hidden pattern and relationship in complex datasets. Lastly, for the maintainability, NN is easier to maintain compared to other systems and ensuring the long-term functionality.
Next, we will go through to the benefit of evolutionary neural network for weather prediction. As we have stated earlier, there are many sectors that highly relies on this weather forecast, and for that very reason, accuracy is the number one priority. Sectors like agriculture, transportation, and so many other factors are highly dependent on this forecast undeniably. So how can this weather forecast help these people in the concerned sectors? For instance, the success for this forecast will be able to provide the concerned parties with timely warning that can help them take timely precautions, thus being able to protect their work and environment. Just as hurricane or heat wave or even heavy rain can affect so many people's life. This shows the prospect ENN has in being able to contribute to the weather forecasting files. Thus, channeling and investing upon this would be benefit a lot of people and sector and even the economy. For the conclusion, weather forecasting has progressed from traditional approach like the window for scale to advanced numerical prediction, and today in machine perfect intelligence system like evolutionary neural network ENN. While conventional systems lack the foundation for modern forecasting, they typically produce errors more so in short-term forecasts. ENN bring welcome novelty to the scenes in its ability to adapt, learn, and integrate both historical data and real-time data to make more reliable and accurate forecasts. ENN addresses shortcomings of existing systems and bring in the union of history and modern technology to provide an even better potential for advance in the field of meteorology, saving life and sustaining economic activities around the globe, and therefore establishing itself as an indispensable instrument for future breakthroughs in weather prediction. That's all from us. Thank you.